All right, so we're continuing on here with our differential equations with y in the equation. This time we're going to find a particular solution. So we're going to anti-differentiate and then sub some sort of initial condition in and find C. But then we're also going to find the largest domain for which the solution applies. That's going to be a little bit foreign to you, but it'll all make sense. All right, so we've got f dash x is equal to the square root of 1 minus y squared. Rewriting that, we've got dy dx equals the square root of 1 minus y squared. Problem, y is in the equation, and we've still got dy dx, so inverting everything, we have dx dy equals 1 on the square root of 1 minus y squared. Now, you might be looking at, now obviously we want to do x equals the integral of that, 1 on the square root of 1 minus y squared. Now this is a pretty esoteric integral, but if you go back to your term 2 work, this one here, it's sine -1 x on a plus c. So we've got a solution just waiting for us, sine -1, so it's going to be y on, in this case, 1, so just y actually. Y on 1 is just going to be y, and then a plus c. Oops. Here's the trick, and something we're usually a little bit lazy about, is stating when this works. So you can't just sub in any value for y. Like if I tried to sub in 5, I could put 5 in here and find the inverse sine of 5, and I'd probably get an answer. But you need to look back at where we started from, 1 minus y squared. Now, this means that y squared needs to be between probably 1 is less than y is less than 1. Probably needs to be between these values here. So let's, I'll just work you through why I think that is. I haven't thought about it too deeply yet. Here's my little bit of thinking. Now the square root of 1 minus y squared, the thing under there has to be 0 or greater. So 0 must be greater than 1 minus y squared. And then if I work on solving this, I'll have y squared must be greater than 1, I believe, and then y is greater than the square root of 1 plus or minus. So that means that -1 is less than y, which is less than 1. So that's an important part of this bit here. We'll use that a little bit later on. Now, it says find the particular solution if f0 equals 1/2. Now, I can probably sub that in now and find out what C is. So we've got, what do we have? When x equals 0, inverse sine, y is equal to 1/2 plus C. All right, so you're going to know, or you should know, that inverse sine of 1/2 is pi on 6. Just try to think of your unit circle here. The 0's there. I can move C over. That would make negative C, but for the interest of saving time here, C is equal to negative pi on 6. So I can now say that x is equal to inverse sine -1 y minus pi on 6. And now I can just rearrange that to make, it'll be x plus pi on 6 equals inverse sine y, which would be y equals sine of x plus pi on 6. Okay, so I've pretty much solved that part here now. We just need to look at the second part, which is state the largest domain for which this solution applies. So you're going to have to be a little bit conceptual here. Now, sine of x plus pi on 6, or sine of I'm just going to sort of make that like a something for now. Sine of anything has to be equal to something between -1 and 1, because that was our range that we sort of stated earlier. So if you think of your unit circle, sine of an angle, because that bit's going to be an angle here, has to be between 1 and -1. And between those angles, you'd have to have sine of some angle between 1 and -1, but the angles are going to be pi on 2 and negative pi on 2. So basically what we're saying is this angle here needs to be between negative pi on 2 and pi on 2. It needs to be between x plus pi on 6, which is less than pi on 2. And I can just solve this by subtracting pi on 6 from both sides, or from all three parts of the equation. All right, and that's going to give me negative 3 pi on 6 minus pi on 6, negative 4 pi on 6, negative 3 pi on 2. And 3 pi on 6 minus pi on 6, 2 pi on 6, which is pi on 3. Okay, and that's our domain for this equation, or that's the largest domain for which this applies. Now, they have sort of provided you with a little sketch here. Now, this is the equation of y equals the inverse sine of x minus pi on 6, I believe. But theirs is this one sort of flipped on its side. Okay, and you can see these. So these would actually be your domain values there. So it's actually by inverting it, because this was x equals inverse sine of y, those domain values are what come about. But that's the sort of graph we're looking at, but take it and turn it on its side. All right, good luck.